What's poppin', dogs? Mr. Allen here, having some fun with polynomials in this video, and I have two rather similar problems here that are worded just a little bit different. So let's start with this one over here. I have if x minus 5 is a factor of p of x, write p of x in factored form. Because right now I have this thing in standard form, and the one thing that standard form is good for is that I can get my y-intercept if I were to graph this. It'd be 0, 60. But I don't get any x-intercepts from factored form, so usually we want to put it in the factored form if we want to find our x-intercepts. I can't factor p of x right here. I can't factor this by grouping. It would not work that way. But I am given a factor of p of x. So how can I use that? Well, what if I were to divide out? If I divide out the x minus 5 from p of x, if I divide out a linear factor from a cubic polynomial, I'd be left with a quadratic. And perhaps I could factor that leftover quadratic. Boom, I get all my factors, write it all out, graph it if I want to, okay? So that's our plan. Let's divide out the x minus 5 from p of x. I'm going to do so using synthetic division because I have a linear binomial with lead coefficient 1. It's the easiest way to divide it. If it's anything else, I generally say go with long division as much as it's a pain. It's usually the safest way. So for synthetic, I'm going to draw this up, big old L-shaped sort of thing there. And I'm going to throw, let's see here, x minus 5. What would make that 0? It'd be 5. 5 is the number that I use for synthetic division. I have to set that x minus 5 equal to 0, add that 5 over. That's the number that I use with synthetic division, okay? That's the number one mistake that people make is they accidentally put negative 5 there. It's what makes that factor 0, okay? We'll have to pay attention to that over here. All right, now I got to put my coefficients. So for the x cubed, it's 1. Over here, it's negative 9. Over here, we've got 8, and then we have 60. So what I do know, though, is if I've been told that x minus 5 is a factor, my remainder right here should be 0. If it's not, then I made some kind of a mistake. I got to go back, take a look, see if I can find it, okay? But I know that remainder has to be 0. Let's see if it works out. So if I drop this 1 here, 5 times 1 is 5. Add them, I get negative 4. Multiply, we get negative 20. Add, I get negative 12. 5 times negative 12 is negative 60. Voila, I have 0 for my remainder. So that checks out good so far. Now what? Well, if this is my remainder, this is my constant. That's my x and my x squared, my coefficients for those terms. That means that I'm going to have x squared minus 4x minus 12 is left over. In other words, right now, let me actually write it like this. Right now, I would have p of x equals x minus 5 times x squared minus 4x minus 12. Now, while I have, there's two factors here, it's not completely factored, right? It's not completely factored yet. So let's completely factor it. Can I factor x squared minus 4x minus 12? Yes, I can. What multiplies to negative 12 adds to negative 4? That would be negative 6 and positive 2. So now I have this part right here fully factored. P of x equals the x minus 5, my original factor that I was given that it could set this whole train in motion here. And then I have the x minus 6 and x plus 2. Boom. Factored form. And I think that's all it asks for, right? If x minus 5 is a factor of p of x, write p of x in factored form. There we go. We have x minus 5, x minus 6, x plus 2. I could graph this thing now if I really wanted. Check it out. Ready? Woo, woo. I'd have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I'd have it at positive 6, positive 5, negative 2. Y-intercept is 60. World's tiniest graph right here. It's a positive cubic. I'd be like, woo. Yay. That was so fun. That was so fun. Maybe I'll zoom in on that on the video. But anyways, there we go. If we wanted to graph it, we could. We got our y-intercept. We got our x-intercepts. Super fun and awesome. All right. There we go. Now, for this one, we are asked to find all the zeros of p of x, given that x equals negative 2 is a 0. And we want to write it in factored form. Right. So for this one, same kind of process. Synthetic division. We'll get this this train in motion, if that's the thing I'm saying now. But the number that goes right here is negative 2. I already know what x equals. It's what x equals goes up here. So if I set that equal to 0, that's what I get. This is already equal to x, negative 2. Boom. Then I'll throw in the 2, the 5, negative 4, and negative 12. And I'm always looking for, if I have a missing term, is if that negative 4x wasn't there, I'd have to put a 0 in place. So if there's ever a missing term, put a 0 in its place, or in long division, a 0x or a 0x squared needs to be in place, otherwise everything gets derailed, okay? So, drop the 2. I am expecting this to be 0 right here. We'll see what happens. Drop the 2, multiply, we get negative 4. Add them, we get 1. Multiply, we get negative 2. Add them, I get negative 6. Multiply, I get positive 12. Voila, we have a remainder of 0 as expected. Constant, that's my x coefficient, my x squared. Nice. Nice. Okay. Now, I got to find my other zeros and write it in factored form. Well, I already got 1 0. Let's put this guy together. I have 2x squared plus x minus 6. And we want to find our other zeros, so I'll set that equal to 0. But how do I solve this? Well, I've got a trinomial, quadratic trinomial. Factoring is my go-to. And if I can't factor it, I'll go to quadratic formula. The way I can check quickly to see if it's factorable, 2 and negative 6 gives me negative 12. Does anything multiply to negative 12 and add to 1? Yes, 4 and negative 3. So it is factorable. Now you could use those numbers along with factor by grouping to factor this thing, or you can do guess and check. And I honestly prefer guess and check in this scenario because there's only one way to get 2x squared. It's with 2x and x. And now I need to think what multiplies to negative 6 while also keeping in mind that these two and these two, when multiplied and combined, have to add up to x. Okay? So how are we going to do it? I'll start with 2 and 3 here. What if I put 2 here and 3 here? And the reason why I picked that is because this would give me 4x and this would give me 3x, which are 1 apart. Now, if I pick this guy to be negative and this one to be positive, I got 4x squared, 4x, negative 3x, that adds it to 1x. These multiply to negative 6. These multiply to 2x squared. I am factored. If you have a different method that you prefer for factoring, that's cool. I do guess and check whenever the numbers are manageable like they are here. And now I can set this guy equal to 0 to get x equals 3 over 2. So it's one of my zeros. X plus 2 equals 0. So x equals negative 2. That's another one of my zeros. And the original x equals, multiplicity of 2. Okay, there we go. That's an interesting graph, right? What happens when x equals negative 2 then? It bounces off of that spot. If we have room, maybe we'll graph it. I don't know if we're going to have room, but we'll make room. We'll make room. All right, so in factored form now, p of x equals, we're going to have x plus 2 squared, and then we'll have the 2x minus 3. So there's my factored form. Got my zeros, got my factored form. We're going to graph this. Okay, we'll graph it right over here just because it's fun. So we got 1, 2, 3, and then over here 1, 2, 3. Well, that'd be 1.5 roughly, right? What's my y-intercept? It's negative 12, so 0, negative 12, and then negative 2, but it's bouncing there, right? And this is a positive cubic function, so it's going to look something like that. So let's fit that to the graph. I'm going to have to bounce off of the first guy right here. Then I'll come down. I think I'm going to bounce, come down, and up. This is kind of in the middle here. I struggled with this in class the other day. Okay, I don't want anyone laughing at me if I don't do it very well. But I think I'm going to come down. Yeah, okay, we're going to figure this out. Woo, bounce. Decent-ish. There we go. P of x. Forgot to label this one. P of x. Boom. All right, very cool. We won't always ask you to graph those. If there's there might be one question like that on a test usually because it's like if you screw one thing up, it gets derailed. A lot of times we'll ask you to graph given different scenario, but that's everything, right? I gave you one of them. You have to find the others, put it in factored form, graph the whole thing. Cool, fun, awesome problem. Thank you guys for sticking around, watching. Hopefully you liked it. Not just liked it, but click, like, subscribe, share it up, tell people about the channel, and have a wonderful, fantastic day. See you later.